Alrighty, everybody. So in today's video, we are going to continue looking at solving systems of equations using elimination. But we're going to be looking at a little bit more difficult problems where the opposite coefficients aren't super obvious right away. We need to manipulate our equations in order to get opposite coefficients. So, the way we manipulate equations is we multiply one or both equations by a number in order to get opposite coefficients. So you'll notice in our first example, timer going off, I can stop. We've got 9x plus y equals 13, and we have 3x plus 2y equals negative 4. So, you have to determine what variable do you want to eliminate, and there's never a wrong answer there. One variable might just be a little bit more work than the other, but you can eliminate whatever variable you want. And in this case, in this system, it doesn't matter which one. So like if I said I want to eliminate the x's, so then I'm going to look at my two x coefficients. I've got 9 and I've got 3. And so I got to ask myself, well, what number do 9 and 3 both go into? They both go into 9. So I can make the coefficients both become 9. I don't need to do anything with the first equation, but if I want to get opposite coefficients on the x's, what I can do is I can multiply the entire bottom equation by negative 3. Excuse me. So the top equation is going to be 9x plus y equals 13. The bottom equation is going to become, after I distribute that negative 3, negative 9x minus 6y equals positive 12. Now from there, what I'm going to do is I'm going to add these equations down, and the x is going to get eliminated. And so next I've got y minus 6y, that's negative 5y. And I have 13 plus 12, and that's going to give me 25. If I divide by negative 5, y equals negative 5. And then I just pick an equation to plug back in and solve for the x. I'll pick the top one. So I've got 9x plus y. Instead of y, I'm going to plug in negative 5 equals 13. So I get 9x and minus 5 equals 13. 9x equals 18, so x is equal to 2. So my solution there is going to be 2 comma negative 5. Now, we could also, in this one, we could have solved for the x. We could have solved for the x first by eliminating the y's. So like, let's say we started with our original system. 3x plus 2y equals negative 4. And let's say we want to eliminate the y's. Well, I've got a coefficient of 1 in my first equation and a coefficient of 2 in my second equation on those y's. So what number do 1 and 2 both go into? They both go into 2. So I'm going to multiply the entire top equation by negative 2 so that the y variables can have opposite coefficients. Oops, and if you'll notice, I made a mistake. You got to make sure you distribute to everything, even across the equal sign. So negative 2 times 13, that's going to give me negative 26. All right, so then we just add the equations together. Negative 18x plus 3x, that's going to give you negative 15x. Negative 2y plus 2y, the y's get eliminated. And then drop your equal sign. Negative 26 minus 4, that'll be negative 30. Divide both sides by negative 15, and x is going to give you 2, which is exactly what we got when we eliminated the y's. So that's what I'm saying. It doesn't matter which variable you eliminate, as long as you're making sure you distribute correctly, add the equations correctly, and solve correctly. All right, so go ahead and try out the practice problem. I will give you the hint. You want to eliminate the x's. So there you'll see the work for the practice problem. Eliminate the x's. You got to get opposite coefficients. So the 6 and 3 both go into 6, so you got to multiply 3 by -2 to get those opposite coefficients. So make sure you get that work down, and let's go on to the next one. What happens if we need to multiply both equations? So like notice on the coefficients in example D of x, you have 4 and 3. Well, what number, like you just got to determine what variable do you want to eliminate. And it doesn't matter which one, but like let's say I want to eliminate the x's. What number do 4 and 3 both go into? Well, 4 and 3 both go into 12. So how do I make 4 become 12? I got to multiply it by 3. So I'm going to multiply the entire top by 3. Now, how do I make the bottom become -12? Because I need those opposite coefficients. I am going to multiply the entire bottom equation by -4. And when I do that, the top equation is going to become 12x plus 9y equals 24. And the bottom equation is going to become -12x plus 20y equals 23 times 4, which is 92. Now, when I add these equations together, the x's are eliminated. 9y plus 20y, that's going to give me 29y equals 24 plus 92, which is 116. Divide everything by 29y, or sorry, just 29. So if I divide by 29, I'm going to get y equals 4. And then I just pick an equation and I plug that variable back in to solve for the x's. So if I have 4x plus 3 times y, instead of y, I plug in 4 equals 8. I get 4x plus 12 equals 8. 4x equals -4. X equals -1. So the solution to that system is -1, 4. Now, just showing you, that way you see it, that it doesn't matter. Let's say we wanted to eliminate the y's. Well, what number do both 3 and -5 go into? Well, they both go into 15. So I multiply the top equation by 5. Multiply the bottom equation by 3, because those are already opposites. One's a positive, one's a negative. So after I distribute this, after I manipulate my equations, you'll see that the y's already have opposite coefficients after I distribute that. Okay? So when I add these two equations together, the y's are going to go away. I'm going to be left with 29x equals -29, and that means x equals -1. So you see, it doesn't matter which ones I manipulate or which variable I choose to eliminate. You should get the same solution. All right, try out that practice problem. Pick a variable to eliminate. Figure out what do you need to multiply both equations by in order to get opposite coefficients. Alrighty, so I chose to eliminate the y's. Doesn't matter which one. If you eliminated the x's, you should have the same solution. I eliminated the y's because those would deal with a little bit smaller numbers. I only needed to multiply the top equation by 2, only needed to multiply the bottom equation by -3. Sure, but I end up getting 1, -5. Alrighty, so what if we have equations that look like this? We got 2x equals 23 minus y, and I have 2y equals 37 minus 3x. Let's say we wanted to keep using elimination. Well, I would just need to get them into standard form. I would just need to get them into ax plus by equals c. All right, so like in the first one, I would just make this become 2x plus y equals 23. I would just add the y to both sides. And then on the second equation, all I would do is add the 3x to the other side. So I would get 3x plus 2y equals 37. So there's my system of equations. And now I can solve this. So what I'm going to do, if I look at this equation, I'm going to eliminate the y's. I'm going to multiply this top equation by -2. So I'm going to get negative 4x minus 2y equals negative 46. And the bottom equation, I'm just going to stay as is, because you'll notice the y's have opposite coefficients. So when I add these equations together, the y's are going to eliminate. Negative 4x plus 3x, that's negative x, equals negative 46 plus 37, which is going to give me negative 9. So x equals 9. Now I just pick an equation to plug it back into. And you could plug it into the standard form version or the original form version. So you could plug it into this version or any of those two equations. It doesn't matter because they're the same thing, just rearranged a little bit. Okay, so let's say I wanted to solve for y. I'm going to plug it back in to the first equation as it was originally given to me. Okay, so I got 2x, so 2 times 9 equals 23 minus y. 2 times 9 is 18 equals 23 minus y. Subtract 23, so I get negative 5 equals negative y. So I'm going to get y to be 5. So the solution here, the ordered pair, is 9, 5. Now, this next question is saying, what is x minus 4y? So here, all I need to do is substitute those variables in to evaluate this expression. So I'm going to take 9 minus 4, and then when I see a y, I'm going to plug in 5. So I simplify that, I get 9 minus 20. Well, that's going to give me negative 11. Okay? So you might see that type of question on quizzes, tests, the SAT, something like that, where you have to find your solution and then you have to use that solution in order to evaluate an expression. Okay? So go ahead and try out the practice problem. Rearrange it first to get them into standard form, and then pick a variable to eliminate and solve using elimination. Alrighty, so there you will see the work for your practice problem. I chose to eliminate the x's after I got them into standard form. If you eliminated the y's, you should get the same answer, same old spiel. We got one more concept to go over with elimination, and that is special solutions. So you'll see what I look like, what I'm talking about in a quick second. So like if I want to eliminate a variable here, I'm going to, I'm going to eliminate the x's. So I got 3x and I have negative 6x. So all I need to do is multiply this top equation by 2. So then that's going to become 6x minus 4y equals 20. And the bottom equation is going to stay negative 6x plus 4y equals negative 7. So when I add these equations, what you're going to notice is that the x's and the y's are eliminated, leaving you with 0 on this side, on the left-hand side. And then 0 equals 20 plus negative 7, or 20 minus 7, which gives you 13. Now, that is false. That's a false statement. And so remember, if you ever are solving an equation and get a false statement, your variables go away, giving you a false statement, that solution is no solution. Which means, remember, that you have parallel lines here. There is no intersection point for these two lines. Now, let's say we have a problem like in G. If I want to eliminate the x's, I'm just going to multiply the top by 3. So that's going to become 15x minus 12y equals 3. And then the bottom equation is going to stay as negative 15x plus 12y equals negative 3. When I add these equations together, everything is going to get eliminated, leaving you with 0 equals 0, which is a true statement, which means that there are infinitely many solutions. Remember, if you end up solving an equation and what you are left up with, what you end up with is that your variables go away and you have a true statement, a number equals a number, that's always true, that's infinitely many solutions, which means that these two lines are the same exact line. They're intersecting for all infinity. Okay, so you might have some problems like that as well. Some no solution or infinitely many, and that's what it's going to look like when you're solving using elimination. Alrighty, so went through a lot of examples in this video. Make sure you're copying those down. Make sure you understand the idea of multiplying equations together. Multiplying equations to manipulate them to get opposite coefficients so that you can eliminate. Alright, so that wraps this up. Time to ask your questions and practice. Have a good one.